Okay guys, so obviously you've finished the work on sampling and now you're moving on to the last part of the experimental method. So once you've done this bit of research methods, we have actually covered all of the first booklet in terms of research methods. And in case you haven't realised, what's included in that first booklet is basically everything that you would do up to and including the point of running the experiment. So at the beginning of your booklet, you've got types of research method, so types of experiments. So we've looked at lab experiments so far. You've then got aims, hypotheses, variables, which we did kind of together all at once. We then looked at extraneous variables and how to control them. So you did a couple of exam questions for me on that last week. Then we've just done sampling, and now once you've got your sample and they're there and they're ready to go and they're going to do your piece of research, the next and final bit of designing a piece of research is experimental design. Now, one of the things that always catches people out is knowing that experimental design is what we call allocation, okay? So I want you to write this, please, that what I've got at the top of my slide now, I want you to write this at the top of your big A3 sheet, that design is how participants are allocated to their different conditions. Now, you already know from your summer work that the golden rule of an experiment is that they are always going to contain a minimum of 2 conditions. Why? So that we can compare and contrast what's happening in those 2 conditions, and that will allow us to see whether or not it is the IV that's causing the DV to change. So, as a researcher, you have now got a situation where you've got a minimum of 2 conditions. You could have 20 conditions, but bog standard, you're going to have at least 2 conditions. You've got to decide who is going to be in each of those conditions. So you've got this lovely sample of people there who you've collected using one of the aforementioned sampling techniques. Now you need to decide who is going to populate your different conditions. So who is going in the experimental condition, who is going in the control condition. Or are you going to not split your participants up? Are you just going to have every single participant doing all of your conditions? This is one of the things that you've got to decide before you even run the experiment. So, there are 3 ways in which you can split your sample up across the different conditions. There is what we call repeated measures design, independent measures design, and a match pairs measures, okay? And all we're going to do in this kind of section of the lesson is look at what they actually involve, and then look at the relative strengths and weaknesses of each one against the others. So if we first of all start with the key features, and on your big A3 sheet you'll see that the top row is left blank. This is what you would put in there. So repeated measures design is what I was referring to before, and we have actually covered this. If you remember, we'd said that a repeated measures design is one of the ways in which you can control extraneous variables. So we'd said that participant variables obviously cause us problems in establishing cause and effect. One of the ways around it is to use repeated measures. So you don't split your participants up at all. One group of big participants complete every single one of the conditions. So that's why it's called repeated measures. They repeat every single condition. So they go in one room to do one condition, then they go to another room to do a second condition, and so on and so forth until they've completed every single one of the tasks. Independent measures is totally different to that. So independent measures requires a little bit of logistic planning by the researcher, and independent measures involves splitting your sample up. So however many groups or conditions you are working to, you need to split your sample up equally so that each condition is populated by the same number of participants. So if you've got 50 participants in your sample and you've got 2 conditions, then obviously you split them totally at random again, and 25 do the experimental condition and 25 would do the control condition. Now, the best way to think of an independent measures design is to think that each participant or each group of participants is totally and utterly independent from the other. They never come into contact with one another. They don't, in most cases, even know that the other half or the other group of participants exist. For all intents and purposes, they think that they are the only participants. They do their trial, and then a second group of participants do the other condition. So they are totally independent. They are totally separate from one another. Matched pairs works on exactly the same principle. So you have these two separate groups of participants, but to make it a little bit more sophisticated and to make it a little bit more kind of like representative, instead of randomly selecting or randomly allocating your participants to the different conditions, matched pairs actually works on the premise that you pair people up on specific characteristics first, all right, that are relevant to your piece of research, and then what you do is you split each pair in half. So one half of the pair does the experimental condition and the other half completes the control condition. So you might be matching them on things like intelligence level or their age or the length of time they've been in a relationship or something along those lines. So you are matching them with a study relevant characteristic, and then once you've got your pairs of people all lined up, you split them straight down the middle. One half of that pair does experimental, one half does control. So independent and matched pairs are going to share some of the same strengths, all right, because they both work on this premise that you've got two isolated groups of participants who don't know that the others exist. Repeated measures is a totally separate kind of concept or idea because you're not splitting your participants up. So you're never really going to be asked that in an exam. Nobody's really going to ever ask you what is involved in a repeated measures design or tell me what one is. What they will do instead is ask you how the participants would complete the conditions, or more likely what the strengths and weaknesses are. So when we're talking about the strengths and weaknesses of these different experimental designs, which you can see here are illustrated. This is all in your booklet, guys, so you don't have to kind of pause it, but if you want to reread it, you can see that this is taking you through how those participants are split up. But what we're more interested in is the evaluation points. And when we're evaluating or discussing the strengths and weaknesses of the experimental designs, these are the three things that you're pretty much always going to be talking about. So you're going to be talking about whether or not they are high or low in order effects, whether or not the experimental design is high or low in demand characteristics, and lastly, whether or not the experimental design is high in participant variability. Now, all of those you can see in this little mint colour. All of those, depending on whether or not they are high or whether or not they avoid that potential problem, all of these affect the likelihood, or the likelihood in this case, that the DV has been impacted. So basically, all of these act as almost like an extraneous variable. So demand characteristics, order effects, and participant variability, if they are present in your research, they have affected your dependent variable, and we cannot be certain that the IV has actually caused the DV to change. If, however, these have been eliminated from your research, okay, then obviously you can establish cause and effect. If you have controlled or avoided, let's say, demand characteristics, then you've got a greater chance or a greater likelihood of being able to say that the IV has caused the DV to change. So if you have a look on your big A3 sheet, what you're about to fill in for me now is some of the strengths and weaknesses. I'm going to fill in one strength or one weakness for each of the experimental designs, and then I'm going to leave it up to you, all right, as part of your homework for this weekend to try and fill in the remaining one. Okay, so I'm only going to fill in either one strength or one weakness for each of the three, and you have then got to take it upon yourself to obviously work out the opposing half, so either the strength or the weakness. Please remember what I said to you in yesterday's lesson, that this needs to be done. I appreciate that I am not there, but you have got this task to do. Okay, I am going to talk you through it. I don't expect anybody to turn up to lesson next Tuesday not knowing this material. So I'm going to firstly start then with repeated measures design, and what I'm going to do with you is I'm going to tell you one of the strengths of repeated measures design. Okay, so one strength of repeated measures design, as you can see here, is we start them by saying that it avoids. So a strength of repeated measures design is that it avoids participant variability. It totally avoids participant variability. So then if you look at the next bit, what else do we need to say? This is because. So repeated measures design avoids participant variability. This is because it is the same participants who are completing both conditions. That therefore means they are being compared against themselves. And obviously the participants don't change. So if we've got it avoids participant variability, and we're saying that it's because it's the same participants who are completing both conditions and those participants don't change, this means that the DV has changed due to the IV. Okay, so this means that we can be almost certain that the DV has changed due to the IV, and that's because individual characteristics of the participants are not changing the dependent variable. So, just to recap, repeated measures avoids participant variability. This is because it is the same participants completing all conditions and they don't change. This means that we can be certain that the IV has caused the DV to change and that it has not been affected by individual characteristics of the participant. Okay, so you can see what I did there. I stated whether or not it was high or whether it avoided one of these things in dark blue. I then explained why using your description from the top row, and then I said what that means for establishing cause and effect. So that's the strength of repeated measures. Now then, let's have a look at independent measures. So for independent measures, I'm going to look at one of the weaknesses, okay? So for independent measures, one weakness is that it is high in participant variability. All right, so they're like vice versa. So it is high in participant variability. This is because participants are randomly allocated to the conditions. Okay, so participants are randomly allocated to the conditions, which results in them being bias. Okay, when you impose any sort of random allocation to your conditions, because as we've previously discussed with sampling, chance doesn't always work the way that you want it to, they all ordinarily end up being biased, and you can't be certain that your conditions are equally balanced. So one of the weaknesses of independent measures design is that it is high in participant variability. This is because the participants have been randomly allocated to the conditions, which increases the likelihood that they're going to be biased. This means that the DV is likely to have been affected by individual characteristics of the participants rather than the independent variable. Okay, so to repeat that, this means that the dependent variable is likely to have been affected by individual characteristics of the participant rather than the IV. Okay. So at the moment, we have got a strength of repeated measures is that it avoids participant variability. A weakness of independent measures is that it is high in participant variability. We're now going to have a look at match pairs. Okay. So, match pairs design, just to recap, is where you have specifically matched participants together based on certain relevant characteristics, and then you've used the same kind of strategy as an independent measures design where you've split them across the experimental and control conditions. So, we are going to go with the strength of match pairs design. So, one strength of match pairs design is that it avoids demand characteristics. Okay, so it avoids demand characteristics. This is because participants only take part in one condition, which means they cannot guess the aim. Okay, so strength of match pairs is that it avoids demand characteristics because they only take part in one condition, which means if they're only doing one condition, they are less likely to guess the aim, okay? If they don't know what the other group or condition is doing, they're not going to know what the aim of the research is. This means that the DV has not been affected by unnatural behaviours and has instead been affected by the independent variable. So by eliminating demand characteristics, your DV has not been affected by unnatural behaviours or unnatural responses, and it has only been affected by the independent variable. Okay, so now what you've got is one strength of repeated measures, one weakness of independent measures, and one strength of match pairs. You need to try now to suss out what are the other evaluation points. Now, just very quickly, with match pairs, the weakness of match pairs is not actually on here. It is a practical problem, okay? Can you think what the practical limitations of splitting your participants in this way would be? For a researcher, what is going to be the practical issue that they are going to face here, okay? So same as what you did with sampling, I would like you to take a picture of that, all right, so that I can see that everybody's done it. And then again, in your blue box, you have got a copy of this exam question. So I want you to identify the experimental design used in this study and then give me one strength and one weakness, and I want you to bring that with you to lesson, okay? Any questions on any of this material, guys, just ask me. You've got all week to get sorted with this. Please, like I said to you yesterday, please don't turn up tomorrow having not done this material, because it's really going to set us backwards. Like I said, I apologise for not being there, but there's nothing I can do about that. So please make sure that you do this work to the best of your ability. Okay, enjoy the rest of your week, guys, and I will see you next Tuesday.